That is called multiplexing. Okay. So these things we have discussed in our Tuesday class. Okay. So now we are going to discuss about on the multiplexing principles. So we can able to understand about the difference between the multiplexer and demultiplexing. Okay. So multiplexing refers to, as per the figure says, multiplexer, it is also referred as MUX, it is called as MUX, and demultiplexer is given as DMUX. Okay. So multiplexer or MPX, anything can be used. Okay. We are having this, it will combine the more number of signals, okay, as a single signal. Okay. That is, let us say that it's a n number of signals. Okay. Is convert to a only one signal. So multiplexer does the n is to 1. Okay. So n is the number of signals are coming. So it converts to a only one signal. And this one signal is communicated. That is, it uses a single channel. Okay. Either it may be a wired or wireless. It uses a single channel. Now, what is the role of a demultiplexer? Demultiplexer, it receives the one signal and converts it to a original n signal. So I can say that demultiplexer performs 1 is to n. You have to remember that multiplexer is n is to 1, whereas demultiplexer is 1 is to n. Okay. So this is the difference between the multiplexer and demultiplexer. Okay. For an example, in our class, we are having, let us say the 50 students we are having in our class. Let us say that for all the 50, okay, they are receiving the call. Okay. All the 50 students, let us say that n is equal to 50. Okay. If I want to transfer these calls, I need a 50 cables. But this multiplexer, what it will do, it will combine all the 50 calls into one call, and this one will be transferred for a long distance, either through wire or wireless medium. And then we use the demultiplexer, which will convert this one signal into again as a 50. That is called multiplexer, demultiplexer. So multiple input signals are combined by the multiplexer, okay, into a single signal, okay, which will be transmitted for a long distance through the communication medium. So the multiplex signals, so what are the signals that are multiplex can modulate a carrier before the transmission. That's what we have discussed. What we need a modulation, because whenever you want to transmit a signal from one end to another end, okay, your voice signal should be modulated with your carrier, okay. We normally called as a frequency modulation or an amplitude modulation. Okay. So this carrier will, these two signals will be combined and this will be transferred, and the receiving end, the carrier will be taken out. Okay. And the communication link, the demultiplexer, what it will do, it is used to recover the original signals. It will recover the individual signals. There are two common types of multiplexing. One is called as your frequency division multiplexing, and one is called as a time division multiplexing. And then there are two methods are available. The variations of these methods. One is called as a FDMA, that is called frequency division multiple access, and one is called as a time division multiple access. So in general, the frequency division multiplexing, it is useful for analog information, and time division multiplexing, it is useful for the digital information. So now we are talking about mostly on the digital era, digital communication. So we can able to understand that for digital, we make use of this time division multiplexing. Okay. One is called as frequency division, one is called as your time division multiplexing. So the time division multiplexing, we know that it is useful for the digital communication, and it is also can be used for analog also. Okay. So the TDM is not only useful for the digital, it can be also useful for the analog applications. And because even if it is analog, we can be able to convert into a digital, or digital, we can be able to convert into analog. It's all quite common. So the primary difference between the TDM and the FDM is, okay, so when you take across a frequency division multiplexing, which is predominantly useful for the analog signals, in frequency division multiplexing, the signals which has to be transmitted are assigned with a different frequency. Okay. So what are the signals you're going to transmit? For an example, if you're going to transmit the 50 signals, each and every signals, we are going to assign a frequency. For 1, 2, 3, 4, up to 50, for each and every signals, we are going to assign a, a, a frequency that shares a common bandwidth. What is a bandwidth? Bandwidth is a space. This is space. Okay. Bandwidth consisting of your higher frequency and also the lower frequency. Okay. So the distance between the higher frequency and the lower frequency is called bandwidth. So I know what is the higher frequency and the lower frequency. So within the frequency limits, I used to assign the frequency for the individual signals. While you talk about on the time division multiplexing, okay, so the multiple signals are transmitted in different time slots. Okay, we talk about other time slots. Okay, let us say that the number one, okay, you transmit the time 0, for 2 time 1 second, 3 time 2 seconds. So we are going to allot the time of 0 to 30 minutes. Okay, so within this time interval, we are going to transmit the signals. That is called time division multiplex. So another important thing what we are going to talk about in the present era is the CDMA. We call as a code division multiplex. Okay. So it is widely useful in the cell phone systems. Okay. So how the cell phone system works? Okay. We are not allotting the frequency, we are not allotting the time, whereas we are going to allot some code. So the CDMA technology is used in the cell phone systems, which will allow the many cell phone subscribers to use a common bandwidth at the same time. Okay, so that is called the CDMA, code division multiple access. So this use system CDMA, it uses a special codes. Okay, so we use a special code that is your mobile phone number. We normally call this as SIM. Okay, SIM stands for subscriber identify module. Okay, so based upon that, you have assigned the individual codes. So these codes are assigned to the user, so we can able to make use of the same bandwidth. Okay, so within the cell phone service provider, they share a common bandwidth. So you can make, I can also use the bandwidth and you can also use that space. Okay. This is called as my space. Okay. Because I can use a common space. Okay. Because your code is different and my code is different. Okay. Here we are not making use of a frequency. We are not using a time, whereas we are using a code. Okay. So CDMA technique is also called as a spread spectrum to make this type of multiplexing possible. Next is called as a spatial multiplexing. Okay, spatial multiplexing, so it is used to describe the transmission of multiple wireless signals. Okay, wireless signals on a common frequency. Okay, so the spatial multiplexing, what it will do, even though you are sharing the same bandwidth for all the users, okay, it will not interfere with one another. One another. It will not interfere. Okay, if it is interfere means what will happen? You will be getting some noise. So one way of doing this, we can make use of the low power transmissions. So the signals do not interfere with each other. The signals will not interfere with each other. When very low power is used, the signals do not travel very far. Okay. So the transmission distance is a function of the power level, frequency, and also the height of the antenna. So these factors can be used to ensure that the signals does not travel more than, say, some 3 miles. Okay, because the 3 miles, the same frequency can be used again to carry different signals. So we are going to make use of the repetition of the same frequencies. Okay, so first it will can travel for 3 miles, and again it will go for 3 miles with a three frequency. Okay, to avoid the interference of the signals. And another technique, we can be able to make use of some controlled antenna radiation patterns. Okay, so these antenna radiation patterns, it will direct my signals to different locations. Okay, so that's such that the signals share the same frequency, do not interfere with each other. Special antennas using multiple transmission and the receiving elements and phase shifting circuits from the beams of radio energy. So where we can able to minimize or eliminate the interference. Our objective is interference. My call should not interfere with your call, even though we share the same bandwidth. So spatial multiplexing is also referred as a frequency reuse because we are reusing the frequency again and again to overcome this interference. Okay. So these techniques, they're not used in the cell phones much. Okay. But presently they are using in the cell phone systems, using the same frequency again and again to avoid interference. And most predominantly it is used in the satellite communication. So by this, you can able to understand students, that is, we are using the mobile cell phones, okay, but we fail to understand that how it works, how the communication system takes place. In frequency division multiplexing, we know that, the signals share the bandwidth of a common communication signal. So all the channels, they will have the specific bandwidths and some are relatively wide. So here we are making use of some coaxial cable. Okay. Coaxial cable has a capability to share a bandwidth. That is the distance between the higher frequency and the lower frequency will be 1 gigahertz. Okay. So the bandwidths of radio channels may vary and are usually determined by the regulations, federations of communication channels, okay, and the type of radio service involved. So whatever the types of channel, so we can make use of the bandwidth can be shared, okay, for the purpose of transmitting the multiple signals at the same time. So this is the figure of electronic circuit shows, okay, how the multiplexers in the frequency division multiplexing system works with. For an example, I'm carry the signal 1, signal 2, signal 3, and signal 4. Okay. So we know that, I want to do the modulation. Modulation is one, okay, which takes the two signals. One is your voice signal and one is your carrier signal. Okay. So the original data modulates the carrier of different frequencies. Okay. So here I use a separate carrier, here I use a separate carrier, here I use a separate carrier, here I use a separate carrier. And once the modulation is completed, so I'm going to have this modulated signal over here, four signals. And then I'm going to make use of the linear mixer or a summer circuit where it will mix all the four as a single medium. So with a single cable, I'm going to make use of a transmitter and it is going to use for the antenna. This is available in my transmitter section. So I can able to understand that the multiplexers are used in the transmitting medium. So the single line carrier, it makes use of a single signal, okay, which will modulate a transmitter. And this transmitter is sometimes an optional because we can able to make use of a signal to carry over here. So the each signal we can able to understand that they need modulator circuits. Okay, we know what is going to be a modulator circuit. Okay, modulator circuit is one. Your voice signal will be added with a carrier. Okay, so as per this diagram, I said that you can make use of the different carrier frequency for the different signals for modulation purpose. So the carrier frequency are equally spaced, from one another as shown in the figure. So for the first signal, there's a carrier frequency. Second signal, carrier frequency. Third signal, the carrier frequency. And the end number of signal, carrier frequency. Okay. So this will be the bandwidth of a single channel. So this I call as a bandwidth of a single channel. Okay. And this is the bandwidth of the overall communication. For the four signals, I have to measure from here to here. This is the overall bandwidth. Okay. I can able to understand that this is going to be the higher frequency and this is going to be the lower frequency for the all the four signals. While I talk about on the individual signal, this is going to be the bandwidth of the individual signals. So when we talk about on the transmitter, okay, so any kind of standard type of modulation like, amplitude modulation, frequency modulation, phase modulation, single sideband modulation, or any kind of modulation can be used. Okay, so the frequency division multiplexing, it process or divides of the bandwidth of a single channel into smaller and equally spaced, and they're capable of carrying information sidebands. So the modulator outputs, so they will contain some sideband information also. So we are going to add some mixer. Okay. So we have to make sure that whether the sidebands are available. So the output signal will be the composite of your all the modulated subcarriers. Now the signal can be used to modulate a radio transmitter, and it can be transmitted using a single communication channel, or else we can make use of a composite signal can become only one input with help of the other multiplex system. This is the receiver when we talk about on the demultiplexer. So from let us say this is a transmitter, what we have discussed previously in this figure. Okay. So from the antenna, the signal will go like this. Once the signal goes, it received in the receiving antenna. The signal is coming and then receive the receiving antenna. Now it will receives and then demodulates. What is the need for a demodulator? Demodulator means it will remove my carrier. Okay, because the carrier does not have any, the carrier does not have any kind of information. So I want to remove the carrier. So the process of removing the carrier is called as a demodulation. Modulation means adding a carrier. Demodulator means removing a carrier. So after removing a carrier, we know that okay, it's a single communication medium. Then I will be making use of the band pass filter. Okay. So these filters will select out the individual channels. Okay. So the one signal will be converted into n number of signals. And then again, we are going to use a demodulator once again to remove this band pass filter carrier signal. And then I will get the original signals. Okay. This is the original signals. 1, 2, 3, N is the original signal. Similarly, you can see here, this 1, 2, this is a signal. 1, 2, 3, N is the original signal. I converted as a single signal and I received as a single signal and then making as a original 1, 2, 3, N. This is the thing of transmitter and the receiver using multiplexers and demultiplexers. So the receiver picks up the signal and demodulates it, recovers it. This is sent to the group of band pass filter. The band pass filter will be what is meant by a band pass filter? Band pass filter means your filter will be like this. A sufficient band will be there. It will allow only the band. So each band will be centered with the some carrier frequency. So the each filter will passes out this channel. It will pass the signal, only the signal it will pass. It will reject all other signal which is not comes under this particular band. Okay. So the band means it will pass the signal only with this available in this particular band limit. Which are the signals are available not available outside the band, it will reject. So a channel demodulator that recovers the original input signal, and we can see that the original signals are 1, 2, 3, and yeah. And what are the applications of the frequency division multiplexing? The first application is the telemetry. So normally, before our final exam, I will be giving you an assignment or a case study. So I will be sharing the question shortly where you need to do the work. Okay. So that will be our second activity number two. I will give in a different way. Okay. That is on the applications. You take one application and then you analyze the application onto that. Okay. I will send you the format and I will send you the details in this week or next week. I will send you. So the telemetry means, so where we are going to collect the signals and generate the electrical signals. Okay. So the electrical signals will vary based upon the changes in your physical characteristics. For example, if you take a temperature, I'm going to convert the temperature into an electrical signal. When the temperature increases, the electrical signal also increases. Okay. So let us talk about a sensor as a thermistor. A thermistor is a sensor which is used to measure the temperature. So the temperature resistance will varies, which inversely with your temperature. When the temperature increases, the resistance decreases because they both are inversely proportional. So the thermistor is usually connected to some kind of resistive networks like a bridge or a voltage divider, okay, to find and also to a DC voltage source. So the output will be a DC voltage. Okay. So for an example, you're measuring the temperature with help of this sensors and also this thermistors, so you'll be getting only the electrical signals. So this DC voltage will change as per your temperature. Okay. Now we are going to measure the measurement with the help of your display or you're making a readout to understand whether DC voltage is very higher, you can able to understand that the temperature is very high. So the thermistor will become a one channel of your FDM systems. Like this temperature will be having all other sensors also, which is having all other different kind of outputs. Some will be having a DC output, some will be having a AC outputs. Okay. So these signals will be amplified, filtered, okay, and then it will be connected to a modulations, and then it will be all the carriers are then added for a single multiplex channel. Okay. So where we can able to understand that, so the varying direct or a alternating current signal will changes the frequency of oscillator, which is operating at the different carrier frequency. So such a circuit is generally referred to as VCO. VCO means voltage controlled oscillator, or it is called as a SCO. So I want to produce a frequency division multiplexing. So this voltage control oscilloscopes, oscillators, so they will operate at a different center or carrier frequency. So the outputs of the subcarrier oscillations are also added. So the diagram I will show you. By this you can able to understand how it works. Okay. So this is the thing of the FDM applications of the telemetry. So let us say that there's a temperature sensor, pressure sensor, and then humidity sensor, and then a water sensor, a level sensor kind, okay, water level sensor. And this sensors I'm going to give to the amplifier. What the amplifier will do, it will improve the strength of my signal. Strength of my signal. Now the signal is given to the VCO. What is meant by VCO? VCO means voltage control oscillator. Okay. What is the role of the oscillator? For an example, you are giving a signal like this. This signal is converted into a sine waveform with the help of the oscillator. So you should know that oscillator is a circuit which converts any signal to a sinusoidal waveform. Okay. Now your signal is going to be a sinusoidal waveform. Okay. Any analog signal, for example, I'm getting an analog signal like this. This signal can be converted into a sine waveform with the help of the voltage control oscilloscope. Now we are using a resistor to limit the flow, the temperature flow. So we are using a resistor to limit the current. And then I'm getting the how many sensors I'm using? Four sensors I'm using. So I'll be getting four signals. Okay. The signal number one, two, and three, and four. Four signals. Now all the four signals are combined together as a single communication medium, and I'm going to give to the amplifier. This amplifier is called operational amplifier. So this is given, all the four signals is given to the negative. Okay. So this amplifier is called summing amplifier. Okay. Summing amplifier means it sums all the four. I'm going to give to the negative of this amplifier, and the positive of the amplifier I'm giving to the minus. Okay. So this op-amp can be classified into two types. One is called as an inverting amplifier. Another one is called as a non-inverting amplifier. Inverting means when you're giving the input to the minus, it is called inverting. When you're giving the inputs to the plus, it is called non-inverting amplifier. Okay. And this is called as the RF. RF stands for feedback resistor. So this is the op-amp circuit. So I'm going to give as a single signal, and I'm going to get as a frequency modulator. I'm going to give a final RF carrier for this one signal. Okay. For this one signal, I'm going to modulate. Okay. So the one signal, let us say like this, and then the carrier signal like this. So these signals will be added with the frequency modulator, and the modulated signal is again amplified to improve the strength. What is meant by an amplifier? Amplifier is a circuit which is used to increase the strength of the signal. For an example, when my voice signal is like this, if I'm going to the amplifier, my signal will get like this. I call this as my weak signal, and this is called as a strong signal. To convert a weak signal to the strong signal, I'm going to make use of a amplifier. Now the amplified signal is given to the antenna. Okay. So this is the antenna. So transmitting. Okay. And then for the receiving end, okay, from the receiving end, okay, this is a receiver. I'm going to use a super heterodyne receiver, and then it's given to the modulator to remove my carrier signal, and then I'm going to give a composite multiplexer signal. Then this is the circuit for the demultiplexer, which comprises of your band pass filter, and then also this PLL is called phase locked loop discriminator, and finally I will get the four signal one, two, three, and four signals. Okay, so where these signals can be used for the record or display, we can able to get. So that is the importance of our today class. Okay, so I just made this one. Okay, yeah. So we can make use of the voltage control oscilloscopes, so oscillators as a to be make use of generating some sine waveforms. So the frequency of the sine waveform generated by the VCO, they will change as per the proportion to your input voltage. So when you increase the input voltage, what will happen? The oscillator frequency also will increase. For an example, the triangle or a rectangular output of your oscillator, which will be usually filtered like a sine waveform with the help of your filter. Okay, so this can be filtering can be done either by a conventional LC filter. LC means inductor and a capacitive filter, or else an active filter with an op amp, or the RC network can be used. So the sinusoidal output is given to the mixer. So as I said, this is called as a mixer. All the sinusoidal things will be given to this mixer. So the linear mixing process can be accomplished by a single resistive networks. Okay. So where we can able to understand that that networks can attenuate the signal, and some voltage amplification is usually required for the practical systems. So where we can able to understand that the way of achieving the same by using the op-amp summer, so that is shown in the slide number 24. So where we can able to have the feedback resistor is there. So there and also the some of other input resistors also there. So the output voltage can be given by the expression minus V1 RF by R1 plus V2 RF by R2 plus V3 RF by R3. So if I want to measure the voltage, okay, I want to take care of this resistor and also the feedback resistor. So what is the amount of voltage I can get over here? I can able to calculate the voltage get to over here by making use of this particular formula. So the output voltage is given by minus. Why I'm going to give the minus? Because I'm going giving the inputs to this minus. Okay, minus. So what is your first input? Rf by R1. Second input Rf by R2. Like that, n number of inputs. By this, you can able to calculate the voltage theoretically. So the oscillators output may be the same and all the resistors are therefore equal. So whenever there's some variation takes place, the amplitude corrections can be accomplished by making the adjustable resistors. Okay. So the output of the summer amplifier does not invert the signal, so it does not have the effect on the content. So the composite output signal is typically used to modulate the radio transmitter. In most of the telemetry systems which uses the frequency modulation, it is possible to use other kind of modulation schemes as well. So the system that uses the frequency modulation for the VCO subcarriers as well as the frequency modulation final carrier is called as frequency FM bar FM system. So this is the receiving system, receiving it. So we can make use of that super heterodyne transmitter energy. Okay. To the RF carrier frequency signal. So we can make use of the FM demodulator, which produces the original composite multiplex signal. It is given to the multiplexer. So the multiplexer will devise the signal and reproduces the original signals. Okay. So the demultiplexer will divide the signals and reproduce. So the output of the first modulator will be given to that. So the each filter passes over the subband carrier and rejects all the others. So the demultiplexing process, we know that how it combines. Okay. So these signals are applied to the FM demodulators. And this is also called as a discriminators. So the circuits will take the FM signals and brings back the original signals. Okay. That's the thing. So the output of the demodulator, I want to bring the original signals. So in most of the signals, so we are going to take across the signals and store for the further purpose for display or storing or any kind of things. We can able to make sure that how it happens. And they can also use the PLL. What is meant by the PLL circuits? They have the superior noise performance. Okay, it is which is used to demodulate the signals. That's what we discussed about on the PLL. So the FDM telemetry systems, even though it is quite expensive, but it's very highly reliable. So it is highly used in aircraft, missile, and also for monitoring of medical devices and even for pacemakers. So students, this is not a very simple task. Just by words, we are telling that you are going to send the multiple signals and you're going to display on the multiple signals. Okay, not like that. It is all the electronics. It's all electronics where you can able to send the multiple signals, where you're going for the purpose of modulation, okay, and then multiplexing, and then transmit, demodulation, and demultiplexing. So this is the four buzzwords what we have to remember. And next we talk about on the another application to the is called as the cable TV. What everybody we are using this cable network. Cable means you are using the cable for individual house connection and for multiple TV signals. The same cable it is used for my house and also for your house. So where it is having the bandwidth of 6 megahertz channel, where we can be able to multiplex on the common coaxial cable. So the TV signals include the both audio and video. Okay. So each signals can be used, channel can use a separate frequencies to produce the frequency division multiplexing. So the cable box itself will act as a filter to select for the desired signal. So the figure shown below, it is for the spectrum of the cable TV. Okay, as I already mentioned that the bandwidth of the individual signals is going to be the 6 megahertz. So here's the 6 megahertz. Okay, it will carry both the video and also the audio signal of your TV channel. So 6 megahertz is enough to carry. So the coaxial cable or the fiber optic cable, okay, why the cables are used? Because the people will say, why can't you use a normal cable? Why are you using the coaxial cable and the free fiber optic cable? Because they will have the enormous bandwidth. So they can able to take even more than 100 TV channels. Because in our house, we used to get 100 or 200 channels. Based upon the number of channels, the size of the cable can vary. So many cable TV companies, they use a cable system for internet access also. Okay. The same coaxial cable is useful for the TV and also the same cable can be useful for internet also. So a special modem. What is meant by a modem? Modem refers to, it is called as a modulator and also demodulator. That's called modem. Modem is expansion. It is not a word for device. It is not a name of the device. Modem is called as the modulator and demodulator, which will permit your computer data to be transmitted and received at high speed rates. And the next application is going to be the FM stereo broadcasting. So where we can able to make use of the two microphones to generate two separate audio signals. So the two microphones, they pick up the sound from the common source. Okay, one is from voice and one is from the orchestra, but from a different direction. One side voice is coming and one side your music is coming. So the separation of the two microphones will provide a sufficient difference between the audio signals. So now when the stereo is reproduced, the two signals can come from a cassette or a tape or a CD or some, what is CD? It's a compact disc or some other source. So the individual signals will be transmitted by a single transmitter, which will be called done by FDM techniques. So this is a general block diagram of a stereo multiplexer module. So we can able to understand when you take your microphones, you're having the two, one is left and right, from where one is audio and one is the music is combined. I'm going to make it as a combination circuit. The combining circuit, going to use the left plus right and the left minus right. The left plus right is given to the linear mixer and the left minus right is given to the balanced modulator as given to the linear mixer. And then you're going to generate a frequency oscillator, which will given to the frequency doubler and is given to the balanced modulator. And your signal and this one will be it is going for the modulation and is given for the linear mixer. That's all. This is the thing. And the remaining things, you're going to make use of a music source, frequency modulator, and then given. Okay. And then RDS data, where we're going to go for the cubic modulator or subband oscillator given. So everything, one signal, two signal, three and four are mixed with a linear mixer, and then is given to the FM transmitter and is given for the transmission purpose. This is called as FM stereo broadcasting. How the voice signals and the music signals come from the two different medium are combined and it was transmitted for the long distance. So the two signals, okay, where we call as a left and right, they originate from the two microphones. And the two signals were fed from the combining circuits, the sum and the difference. So the sum is a linear algebraic of the left and right signals. So the composite signal will produce a single microphone will produce to pick up the sound. Okay, it's a signal that monaural receiver will hear. The frequency response is about 50 to 15 hertz to kilohertz. So the combining circuits, what it will do, it will invert the right channel signal, thereby subtracting from the left channel to produce some L by L minus R signal. That was I showed in the diagram. The two signals, so the L plus R and L minus R, they are transmitted independently and then they combine later in the receiver. Okay. So the L plus R and the L minus R, they are given separately, whereas it will be combined in the receiving end. So what is meant by L minus R? It is useful for amplitude modulates at 38 kilohertz in a balanced modulator. So the balanced modulator suppresses the carrier but generates some upper and the lower sidebands. So the resulting spectrum will be given like this. This is called as a suppressed subcarrier with L minus R. Okay, and also the other signals like RDS and SCA as per this particular diagram. So as shown, the frequency range of L plus R is some nothing. So the frequency response of FM signals will be from 50 hertz to 15 kilohertz. Okay. So sidebands L minus R, they take another set of frequency. So the DSB, okay, suppressed carrier is algebraically added and transmits the L plus R. So the the both two signals that is called the L plus R and the L minus R. They are generated with the oscillator whose output also modulates the main transmitter. So the 19 kilohertz oscillator drives the frequency doubler to generate a balanced modulator of 38 kilohertz. So some frequency modulation stations also broadcast some additional signals, which we term as a SCA, subsidiary communication authorization symbols. So they take the location of 67 kilohertz. Okay, so SCA signals are used to transmit the weather, sports, and financial information. The additional things. Okay, so that is additional things. So where I'm playing some music. In addition to that, I need to give a space for others to come in the middle. Okay, to give some information about the weather, sports, and financial information at the middle while going across on my FM transmission broadcasting. So this SCA FM will receives these additional information signals. So the SCA portion is useful for broadcasting background music for elevators, stores, offices, and restaurants. This SCA portion. Normal is different. SCA portion means, sometimes you'll get some advertisements in the malls. Okay. Sometimes you'll get some breaking news. So that will be taken, directed by this SCA broadcasting. So if SCA system is used, the 67 kilohertz carrier will be added to the L plus R L minus. So not all the trans stations will transmit SCA, but some transmit SCA with the several channels. The alternate service provided by some FM stations is called the radio data systems. It is widely used in the car radios and some home stereo receivers. It allows the digital data to be transmitted to the FM receiver. Some examples include station call letters and location and the travel and weather data and short news announcement. That's why I see it. And the RDS is useful to transmit the name of the artist of the music selections played. Okay, so I can say that in this particular figure, these two things are add-ons. Okay, this SCA and the things SCA and also the RDS. Okay, so the transmitted data will be displayed in the LCD display. So the data to be transmitted will take the other position. So third harmonic of the 19 kilohertz can also to prevent interaction with the stereo signals. The form of phase modulation called QPSK, it is used to modulate the subcarrier. The data transfer rate will be of 1187.5 bps, bits per second. And the other FDS system, all the subcarriers are added with the linear mixer to form a signal for transmission. So this signal is useful for the modulate for the carrier. Okay, FDM signals will take a large portion of the frequency spectrum. Okay, so there's a sufficient spacing will be there between the FM stations, so additional information can be added. So we have to keep in mind that the additional subcarrier will reduce the amount by which the main L plus R signal can modulate the carrier. So the maximum total modulation voltage is determined by the legal channel width. So this is a receiver end. So the receiver that will go for demodulation and all the signals will given to the LPF and BPF, low pass filter and the band pass filter, and the linear combiner and the frequency doubler. And finally, it is given to the speaker or the LCD display or with the power amplifier. And that's what is given over here. So broadcasting. Okay, so it's a simple exercise. Okay, so a cable TV service, okay, it uses a single coaxial cable, okay, with a bandwidth of 860 megahertz. It is used to transmit multiple TV signals to subscribers. Each TV signal is 6 megahertz wide. So I want to calculate how many channels this particular thing can be carried. Again, I repeat the question. A cable TV service, they use a single coaxial cable for a cable TV. So this cable TV cable is having a bandwidth of 860 megahertz. So as I already mentioned you, based upon the bandwidth of your coaxial cable, you can determine the number of channels. Okay. So I can able to understand that each TV signal is having 6 megahertz wide. How many channels? So it's very simple. So 860 is the bandwidth of your cable divided by each TV signal 6 megahertz. So 860 divided by 6, so it is equal to 143. So by this cable, you can able to carry 143 channels. So in your television, you're watching so much of channels. How it is happening by making use of this? So that's all for the today class, students. So today, the takeaway of the today class is going to be a very simple thing. That is how we are transmitting the information and how we are making the information from one end to another end, with help of the different things. So that is our discussion for today. That is our discussion for today we have taken. And we also understood that, so how the television cable signals work with and what are the signals. Okay. So whenever you get a free time, you please go through my materials, which I already shared in your Google Classroom. Okay, so you can share, you can see how it is happening. So we are not skipping any kind of topics. We are texting, we are discussing with all the topics how it works. So don't ever think that in your television you are watching the so many channels, but you should think that there is also a mathematical calculations. Okay, simply we can say that my television shows 100 channels, 200 channels. How it is happening? It's all because of the coaxial cable. How it is transmitted, how it is multiplexed, what is the need for the bandpass filter, what is meant by the voltage controlled oscillators, everything we need to know. So then only we can realize. Okay. So I recommend you people that, you don't study engineering, you feel engineering and technology. Okay. Don't just study the part. Okay. You don't study, okay. You don't study only the part, what you're going to see. You don't study the things, what you're going to do that. Okay. So where you can able to understand that most of the cases, you feel engineering. You take your these concepts to your heart. So where you can realize that what are the things you're looking around, it's all the science and technology. You can ask a question by knowing this, what I can do with that. You can do some wonders. You will create some products. Even there are so many issues available in the communication systems. Try to do some projects on this one. Okay. So thank you so much, students. The next week we are going to meet. Okay. So the next week we are going to discuss